Hello and welcome back to Physical Science Online once again. Today we are doing our Speed of Sound lab. This is a fairly quick lab that encompasses a lot of more higher level thoughts in it. So you're going to follow along with your worksheet. You're going to enter in what I do, and it's more of kind of a cool lab. We are proving what the speed of sound is. That's for sure. We are using our speed of a wave equation. That's for sure. But we're also looking at some stuff like different mediums. We're looking at different frequencies, and it's kind of odd how this lab can work. Basically, no matter how you do it, you'll see in the instructions how it says you can use basically any PVC pipe that you want to. You can use any tuning fork frequency that you want to, which there's a few of them. And you just have to follow the directions, and you can actually do this if you had some sort of a tuning fork or even frequency generator at home. You could do this at home, but I wanted to give you some numbers in case you don't have those materials at home. So that being said, let's get to this. Since I've done this a few times, it'd probably go a little faster than it would if you were in class. But if you're at home, you're VLA, or you're quarantined, or you're just absent, this will get you the bulk of what you need to get this lab done. So here's your basic setup. I have, like I said, a tuning fork and a PVC pipe, and then a column of water, which is just a really large graduated cylinder. That's our best column of water that we can do. And I'm hoping that the audio is going to come through the computer just fine. So if you haven't used a tuning fork before, basically when you hit it, I even have a little fancy tuning fork hitter here. It gives off a frequency, a set frequency. If you've taken music class, you know a little bit more about frequencies and the tones that come out. This one is set at 426.7 hertz. So that's the frequency of this tuning fork that I'm going to use. The tuning forks have set frequencies. When you hit them, they give off the same frequency, no matter what. Then you would normally put your PVC pipe in the water, and you're going to put the tuning fork above it with your ear next to it, and you can actually hear a point where it gets really, really loud. The amplitude goes way up. Right there is where mine happened. Let's see if I can get that to happen through the... See how it's louder right there, quieter right there, louder right there. That's what you would do during class. It's a little bit easier if you're in person, but that's the stuff we would take. And then we're going to measure that length. So let me make sure I have this marked correctly. Right there is where I'm really loud. So we're going to measure the length of the tube from right there to the top. It's actually kind of cool. I can get my ruler right in there, right to the water level. It is exactly 19.6. Oh, no. I had it in the water a little bit. 19.4 centimeters. 19.4 centimeters is the length at which I got that higher frequency, or higher amplitude, I should say. And then the diameter of this tube is 2.4 centimeters. 2.4 centimeters is my diameter. So on my sheet, diameter is 2.4, length is 19.4, and my hertz, my known frequency, is 426.7. There's your data. Now you can use that data to do your calculations. Follow the instructions as closely as you can to see what the speed of sound is. Speed of sound in air is a pretty set value. And then the rest of lab is talking about how that can change based on some other variables that would happen. So there you go. That is your lab. The rest of it I think you can do on your own based on that data that I gave you. Not quite as cool as doing it yourself, but at least you got something. And now you know how to calculate the speed of sound using the frequency equation. Thanks for playing along, and have a good day.